In this video, I'm going to show you how you can create a table GUI component. The table GUI object is a great way to display a list of data to the user. With the table structure, we can provide a list of multiple items with details about each. Since we're creating our own table from scratch, what we put in the table is completely up to us. The table should be generic enough to be used in many situations, but allow for enough customization to make it fit wherever we want to put it. For this requirement, I've decided to make the table cells customizable to allow custom code to be run inside each cell if we want it to. This should greatly expand the options for what we can place inside the table. Let's take a look at this in code. Our table is going to contain a list of rows, which each contain a list of table items. These will be the row cells. This should enable us to easily add new rows to the table simply by creating a list of table items. Table items are going to be somewhat complex. Table items will have an event for when they're clicked. They will have their own draw method because they are responsible for drawing themselves. Next, they'll have an update method so we can run code inside each cell like I mentioned before. This abstract class will be implemented in various ways. For example, a simple string table item will just contain some string text and draw that text when it's requested to draw. A distance table item is a little more complex. It's going to take two transforms, and it's going to calculate the distance between the two and display that distance when it's requested to draw. This will utilize updates to update the distance. Finally, an even more complex table item is the directional pointer. This item will take a texture and two transforms, a source and a target. It will create a rotatable GUI item, ideally with a texture like an arrow, which will then point from the source to the target. When drawing, this will draw the rotatable GUI item to point the direction from the source to the target. In the update method, it's going to update its rotation to ensure that it's always accurate. This method is also going to have a getAngleBetween method that it will use to get the angle between the two transforms. Creating a table starts with defining the size, the cell height, the GUI skin we want to use, and what columns will go into it. The table is going to attempt to use a style called table cell within the skin passed in. If the style is not found, we're going to utilize the default of the skin box. We do this because inside GUI skin, when trying to use a style that doesn't exist, it will automatically default to something else, but it's very slow. We want to use this as a shortcut so we don't have to do that every time. Next, we're going to calculate the column widths based on the size of each element in the headers. Next, adding rows has a few options. Well, each time we add a row, we're going to check the number of items to ensure it matches the number of headers. If it does not, we're going to display an error. Next, our update method is going to go through and update each cell to update the code that runs inside each cell. Our drawing table method is going to begin a group for the size of the table, and for each of the column headers, it's going to draw a label that matches the name of that header. Then for each row, we're going to go into each column and have each cell draw itself. Let's take a look at an interface that implements this. This test table interface is going to create a new table. It's going to contain a nested list of table items to define the table data. The columns we're adding are object name, direction, and distance. When populating the data for this table, we're going to get all of the game objects in the scene that have the tag table track. For each of these objects, we're going to add a new row to our table. The row is going to consist of the object's name in a string table item, a directional pointer table item using an arrow texture, the transform we have this interface attached to, along with the transform of the table track item, and a distance table item that will include the same. Updating the table data, we'll simply call our test table update to update all the code inside each cell of the table. Let's take a look at this in Unity. Here we have a scene with our graphical user interface object, which has our test table interface attached to it. Additionally, we have 4 objects, all with the table track tag, and each of these objects has been added to our table, along with a directional pointer pointing from our test object to the track object. Finally, a distance showing the distance between the test object and our tracked objects. We can see moving around the scene that these values update not only the directions, but the distances. What we've created here is a simple HUD for nearby objects. This will give the user information about the direction of objects in their scene and how far away they are. In this video, I've shown you how to create a table GUI component. Tables are used in a lot of places within games, from scoreboards to HUDs for nearby objects like we've created here. and they are a simple way to display data to the user that they're familiar with. The table we've created here is very customizable, not only with the type of data and live feedback it can provide, but with the styles Unity provides, we can make the table look however we like. We can extend this table to include other GUI elements like progress bars, buttons, or text entry fields.